Good evening, students. Welcome back for another very important lecture. I have chosen this topic because this is a very vital and important topic of the D block elements. And questions are asked on this. Not only questions are asked, but there are many possible questions which are there from this topic. And I have discussed a part of it in the previous lecture, but that was not complete because considering the type of question, number of questions which will be there, we are going to solve some problems and going to give answers on what is the trends in the standard electrode potentials, how these values are helpful in finding the stability of the different oxidation states, which is oxidizing and which is reducing, which state is going to act as an oxidizing agent, which is going to act as a reducing agent, and what are the possible reasons for that. That's why I am spending some time on this because this topic is very important, students. The standard electrode potential trends, and there will be a lot of questions on this. All right, student. First thing I have to learn. First thing I have to learn. See, I have given some idea to you, students. I have given already some idea. What idea I have been given, student? What is standard electrode potential? And you have seen in electrochemistry topic also, students, we have calculated the E naught standard reduction potential value, standard reduction, which was given in this form, and then plus 2m. Sure?
Yes, sir.
And you have been given standard conditions of 298 Kelvin, 1 atmospheric pressure. And in this case, we are talking of transition elements, student, transition elements. And we have already idea that the values depends on what factor, student, on what factors these values depend. They, we have already told you, students, there is a delta sublimation. There is a delta.
The
Here I am
hydration.
talking of mostly M2 plus. Here I am talking of M2 plus 2M. Therefore, I am talking of delta 1. This is my enthalpy, first ionization. Then I am talking of delta 2 ionization enthalpies. These are ionization enthalpy, student. The third thing which I am talking, because what is
Hydration.
happening, M2, I should something like M2 aqueous. I am talking of solution, in the solution, student. Then the third thing which is going to be there is delta hydration H. So you can see that on what values it will depend. Very important. The students are not aware of this. So it is not a one thing, student, because if these which are positive and which are negative, delta atomization or sublimation, delta sublimation or atomization, this is positive. And
Okay.
student, delta IH is positive. And students, delta, this is I1, delta I2 is also positive.
Positive.
But delta hydration, student H, this is negative. So the total change in enthalpy, student, the total change in enthalpy, if I put the standard values, okay, standard values, okay, okay, then the total is the sum of all these. So why the values are coming negative or positive, students? That is the addition of all these things. So you have positive terms and negative terms. The sum is delta sublimation. You are saying this value is positive, then delta 1 H positive, positive, delta 2 H positive minus delta hydration. This is going to add up to give me the values of this. Therefore, student, what was done was for the transition 3D series, we decided to calculate the values. And
Okay.
in this here, we are giving you a thermochemical data in kilojoules per mole for first row of transition elements from M2 to M. What I am talking is M2 to M. Okay?
Okay. Okay,
All
sir.
these values I am listing for formation of the two ions, M2 ions. And these two ions will then go in the water and they will be hydration energy. Okay? That
Yes.
value is negative. This is the hydration enthalpy. For example, if I take the titanium student, the delta atomization or sublimation is 469. The first ionization 661, second ionization 131,
1, 3,
hydration enthalpy 1866.
minus.
1866, that's quite a good value. And then the value is becoming negative.
Okay.
That means the hydrogen enthalpy is negative value is quite high as compared to the values which are involved in atomization and ionization of the titanium 2 plus. What is happening? You had titanium S, it was converted into titanium where sublimation first of all. It is
Yes,
first
sir.
converted into, let me see the step student. Okay, so there should be no confusion. No confusion. Should be very important. Okay. What I am saying, for example, in the titanium student, if I take the case of the titanium, what is happening? This is the first step. So this is going into gas. That value is how much here? Plus 469. These are kilojoules per mole. After this, what happens is it is moving from PIG plus, what is the value? Plus 661.
Plus 661.
And then PI gas is going to student PI 2 plus. How much? Plus
1310.
then TI2 plus gas is going to go to TI2 plus aqueous.
Aqueous.
And this value will be
Minus 189. Minus 1866.
so these are the values. After using all these values, I get delta as total. Delta as total as we have shown here. Then the value of E naught is calculated. There is a formula for that, which we are not talking how what formula is there, what is the exact conversion factor which is there. So that the values delta G is equal to minus NF, all these formulas are there, which we are not talking here. So here the value is coming to be minus 1.6. This value is negative. As
Yes,
you
sir.
can see, this value is quite a good negative, quite a good negative. What is the meaning of this student when this value is negative? First, let me see what is the meaning of this. You are saying titanium 2 plus 2 electrons. Titanium 2 plus 2 electron to titanium value is E naught minus 1.63 volt. What it is telling me? That this value is quite a good negative. So this is not going to go towards forward direction. This
Okay.
negative, negative. So that means titanium 2 plus is more stable state
Yes, sir.
than titanium, than titanium. So this is not going to get reduced, but reverse will be plus 1.63. Reverse is, that means they can give electrons if the value of someone is uh, comparable, I mean, more than that. Positive, more positive to it. It can give the electrons. And then let me see the electronic configuration of titanium student. What is titanium? Scandium, titanium. What is that? 4s2, 3d2.
3D2.
So one, two electrons are left. This is a 3d2 configuration. This is value is minus 1.63 student. And other values, because this value is not dependent on one factor. How many factors they are? Four factors.
Four factors.
Four factors. So if we say ki somewhere the atomization energy is very high, that will depend on the how strong bonding is there, metallic bonding is there, how strong metallic bonding is there. If
Okay.
the number of unpaired electron increases, then you know atomization energy increases. We have shown a graph of that also in the previous lecture.
Yes, sir.
And
Yes, sir.
ionization enthalpy depends on the size. You see, the smaller the size, the higher the ionization enthalpy. That also we have shown you. This was just to tell you that how these values are calculated. Now, what was done was when these values were calculated and they compared the observed values. Observed means experimental values. One is the observed values, second is the calculated values. Just as what I'm calculating by using these values, and experimentally I do the measurement. Experimentally I measure the value. Student, how experimentally you know that by using electrochemical cells. How do you measure?
Yes, sir.
In electrochemistry, you have seen half cell, then you
Yes, sir.
measure the values.
Yes, sir.
And there are two colors which have been shown. What are the two colors?
Green and red.
This is observed,
Red is observed and green is calculated.
and it seems there is a quite a good matching between the two, except in few cases. See, they are overlapping in most of the cases. There is a small difference.
In cobalt and nickel.
On that we will see what is the first observation is that student. What is the first thing I observe from these values have been calculated? Standard electrode potential, and these are the elements: titanium, vanadium, chromium, manganese, copper, zinc. These atomic numbers start from 22 students, titanium to zinc. Scandium is not listed. The reason we will tell you everything. So first thing you can say that there is a good agreement
Okay.
between the two values. There is a good agreement. So basically, what we are saying, how through we calculate, they are in agreement with the experiment values. So we calculated by this method as we have shown, and these values except one or two, they are in good agreement. Now the question we have said is that uh, second point. Do you? But there is no regular trend. I don't see that it is increasing or it is decreasing. There is
Yes, sir.
some irregularity. Second thing, what I see in this graph, there is a irregularity, students, in the trends of, you have noted down everything, standard electron.
Yes, sir.
So the question will be there. First question, why there is a irregularity in the standard electrode potential values of transition elements? First question, what is our answer, student? Question answer session starts right from the graph as I see. How many questions can be framed? We will see that now. On this is a very important topic. Question will be 100% there on this in every exam. I'm saying here some students don't spend that. It needs time, attention to understand what we are talking about. So 100% question will there in all competitions also. So what answer you are giving, students? Tell me fast. We have only 30 seconds. Why there is a irregularity in the values of the standard electrode potential of transition elements? What answer you are giving? Because these values are dependent on how many factors? Four
On four
factors.
factors.
And there are
Yes, sir.
irregularities. There are irregularities, student, in the variation of ionization enthalpies and hydration enthalpies. There are
Okay.
irregularities already in the ionization enthalpy and hydration enthalpies of the transition element. That's why these values are irregular. Question answered.
Okay.
Question answered. ठीक है. You are keeping a record of everything. I mean,
Yes,
well,
sir.
you will get videos also. No, no problem. This I can rub this right hand side with your permission, students. You are understanding everything. Pay attention, pay attention. That is my question. Keep your energy high, students, or we will fall asleep and the whole game is over. The questions are so, this question involves quite a good amount of thinking, and wrong thinking means wrong answer means 0 mark. Correct answer means 4 marks in your competition paper. So students have to be alert. CBSC or any exam. The problem is already facing students a lot of pressure students facing
Yes, sir.
because of the pandemic. But I said we have to face it and face it. Students who are determined, they will have no problem. Others will make excuses. No excuses are heard anywhere in the world.
Yes, sir.
So we have to prepare well. I have to work hard for all these things. I will try to collect some data on various questions which were asked. Every time I'm saying this is a question, so we have to answer everything, students. Okay, let me just get out of this. Hmm. All right, students. Okay, see how we will be answering the question that is important. Students who will not think before answering the question are always wrong. So another, what another feature I see here, what I see that in 3D series, student, all E naught zero values are negative except
Uh, Here E naught,
values are except copper.
except
What is the value of copper? 2 plus 2 copper, student. I mean, what when I write this
0.34. Yeah.
value we I remember by now. In
Yes, sir.
electrochemistry also we use it a lot, student. Plus 0.34 volt. ठीक है?
Yes, sir.
The question is asked to the students many times. Why? What is the answer of the student? What answer you are giving? I will give only 1 minute. You have the thermochemical data also from the book. We have taken this table just to be sure what we are talking about.
Sir, for
Where
copper
is
we,
where is copper? This value, this value, this value.
sir, for copper, delta H hydration and delta H sublimation and delta H ionization are very high, and delta H hydration is not very high. So,
So what we are saying, student, what we are saying in the case of the copper, the value is positive in the exam because the high values of delta atomization plus delta ionization enthalpy 1 and 2 are not compensated by the low hydration enthalpy. I may not write low here, doesn't matter. By the hydration enthalpy value is not able to do that. I'm not saying it is that low. I should not put it this. It is not compensated by the hydration enthalpy. That is the end of the answer. That's all.
okay.
Question 3. No need of writing this. Okay, student, we have answered this question. Further question, what we see, student. As you see in this, what is happening at the manganese? Manganese. What we see something in the manganese, student? What we see in the zinc? What we see in the zinc? This was my zero value. As you can see, this is zero. They are negative. Above it is positive. Copper was here. Positive. Okay?
Yes, sir.
This is a negative. Zero
Yes, sir.
value. My zero value. All below these are negative. So then what is happening? This is my nickel and here is my cobalt student. What is happening to these values are coming down student. So this first question now. The E naught student Mn2 plus 2 Mn. What is that? Where is manganese here? What is the value? Is
Because
more negative. Why? Now question. Okay, you have 30 seconds. How will you search the answer?
sir, because of uh, manganese 2 plus have half filled D subshell. That's why.
Okay, let me see. Now that we have started searching for the answer, how do we go it? So I always said that we should try to find, if possible, not always. I'm saying, try to search the electronic configuration. Okay, one possibility. In many cases, I'm saying students. What is the manganese student? This is what is the configuration of manganese 3D,
3D5 4s2.
and then what is Mn2 plus?
Mn2 plus with 3D5.
That means you are going from Mn2 plus adding two electrons. You are going like this.
Yes, sir.
This value is how much? Read it. Minus.
Manganese minus 1.18.
Okay, volts. Now this is a negative. This is a negative means this state is more stable. But in other words, I'm trying to say the lesser the value, the more stable is the oxidation state. Yes or no?
Yes, sir.
I started talking with you in differently. More stable oxidation state means lesser, more negative E naught. That's what you are saying?
Yes, sir.
Convinced? Okay. That means because we have already said, because in Mn2 plus, what answer is there? Mn2 plus, the manganese has 3d5, which is half filled. Okay?
Yes, sir.
Extra stability. Half filled orbitals are more stable because there is exchange energy student which they gain out of that. Lowering of the energy takes place. Question answered?
Yes, sir.
That question has been asked in paper. That's why I'm taking it one by one.
Okay.
Every question has been asked. Question 5 students. Now the next question student, what I'm saying, E naught Zn2 to Zn. How much?
Zn
Minus 0.
minus 0.76.
So why it is also other value you see 0.28 and this point minus 6. What is the reason student? This also has large negative value. Why it has more
So
negative?
because
That means you are saying Zn
it
plus
has fully filled. It has
2
two
Zn.
again.
What is
Yes, sir.
happening students? This value is this minus 0.65. So Zn2 plus is stable, is more stable than Zn, in other words, otherwise it will convert into it. So what is the configuration of Zn2 plus?
Zn2
3D.
plus will be 3D10.
So it has a completely filled d orbital, stable. Answer is according to the question. So 3D10 stable configuration. Therefore Zn2, therefore zinc acts as reducing agent. Acts as a
Reducing agent.
question could be put in a different way, different form. The answer lies the same. When I say it is a reducing agent, you say okay, because the standard electrode potential is negative, therefore it is a reducing agent. My answer is correct in the paper. Got my point?
Yes, sir.
Why? He says zinc acts as a reducing agent. Why? You said because the standard electrode potential of zinc is minus, and one value I
minus.
remember now, minus 0.76 volt. Therefore, it is a good reducing agent. All right, student. This is answered now. Let me see the nickel. Where is nickel now?
Nickel is
Question
here.
number 6.
Minus
Ni2
0.25.
plus 2 nickel. What is the value, student?
Minus 0.25.
Minus 0.25. So, what is nickel 2 plus? In nickel, what is the
Nickel.
configuration of nickel? Nickel, where is that nickel?
Uh,
What is the atomic number of
3D8
nickel?
4s2.
What is the atomic number?
28.
20,
28.
28. 28 means then what is the configuration?
3D8 4s2.
4s2 3d8 and nickel 2 plus
3D8.
3d8. It, configuration does not answer the question. Here, your electronic configuration is not working. Then let us see what is the nickel. This is my nickel, student.
Yes, sir.
Okay, let me see very carefully. Nickel 431417, and this value, some answer is coming. It is not a question of stable configuration.
Yes, sir.
Configuration stability is not involved. Neither half filled nor completely filled orbitals are there. But the answer of nickel 2 plus has been asked in the paper, student. Our answer is it has a high hydration enthalpy. Got it?
Yes, sir.
How much is the value? Minus 2
Minus 2121.
kilojoule per mole, students. Question answered?
Yes, sir.
Question answered. So what I am trying to say, students, every time the answer may not be same. We have to explore all possibilities. All these questions have been asked in the paper. Which question may be asked, we don't know. But most of the times, first thing we do is search in the electronic configuration. If extra stability is coming to a particular oxidation state, that may be our answer, students. But if it doesn't, then we have data of thermochemical, which we have already said in the very first line. These values are decided by sum of all these values. Where hydration enthalpies become important, they have to be answered in the paper. Nickel,
Okay.
answer hydration enthalpy. Got it?
Yes, sir.
Okay. This is very important. There will be question on this student, and most of the students have just forgotten anything about it. They don't know. They have not seen it. This doesn't make any sense. One, two student told me, sir, I don't look to these graphs. They are difficult. What difficult if I don't understand what answer I will give? Nothing. I am telling you questions are coming. Okay, students. Okay, students. And see, one more case. If I see where is vanadium, student? Vanadium
Vanadium is minus 1.18.
minus 1.18. Okay, let us go further. We will come back if we require. Now the story is, student, up to now what I was talking was M2 plus, ठीक है, 2M.
Yes, sir.
Now I am going to compare standard electrode potentials of students M3 to M2 plus, M3 to M3 plus ions. ठीक है,
Yes, sir.
M3 to M2 plus ion. For example, student, देखो, you have Mn3 plus, ठीक है, If it gains one electron, students, it will become Mn2 plus.
2 plus.
What is this value given, student? Tell me.
For Mn plus 1.57.
This value is quite high and positive. Therefore, that shows that Mn3 plus, tell me, is it oxidizing agent or reducing agent?
Sir, it will be oxidizing agent.
Oxidizing agent is what? What is oxidizing agent? Which undergoes
It undergoes reduction.
reduction. It is a reduction reaction. It is a reduction reaction.
Reduction.
Therefore, you are saying it acts as an oxidizing agent. Mn3 plus is acting as an oxidizing agent. The value is positive. Then what is the reason for this student? Question has been asked. Question has been asked, student. What is our answer, student? In other words, what I am saying, student, question is like this: Mn3 plus to Mn2 plus E naught is plus 1.57. Which is more stable? Which is more stable oxidation state of manganese? Mn2 plus or Mn3 plus? Okay. Which is more stable? Out of the two, which is more stable oxidation state?
Uh,
Now we have started thinking, applying our mind. Naturally, this value is positive. This is more stable. But I'm saying Mn2 plus is more stable than Mn3 plus. If its value is lower, then this state is more stable. If it is plus high, then it is more stable. Mn2 plus is more stable. That's what we
okay.
are saying. Yes or no?
Yes, sir.
This is
Okay.
more stable. Why it is more stable than question? Simply, what is the, then I'm searching the electronic configuration. What is the electronic configuration of
Half
this?
filled.
It is
Half
3D,
filled d orbital.
3D5. And what is the electronic configuration of Mn3 plus, students?
Mn3 plus will be 3d4.
3D4, 4s0. Therefore, it is Mn2. What answer we are writing? Mn2 plus is extra stable, half filled, D5. Therefore, it will be difficult to remove an electron from here. It will be difficult to remove an electron from here, students. Or it Mn2 is more stable than Mn3. Therefore, Mn3 will go to Mn2 plus oxidation state.
Okay.
Answered question.
Okay, sir.
Okay. Now, I have not given the data of scandium. Why? Why the scandium data has not been given, student? Because if I go from scandium 3 plus to scandium 2 plus, E naught value is very small. The value has not been given in the book.
Okay.
I am concluding that this value is very low value. If this value is very low, what it means, student? Question, questions. What it means, student, value is very low. Which state is more stable, scandium 3 plus or scandium 2 plus?
Scandium 3 plus will be more stable.
Scandium 3 plus is more stable than scandium 2 plus, so much so that Sc2 plus does not exist.
Okay.
Now, what answer you are giving? What is the reason?
Sir, because in Sc3 plus we have noble gas configuration.
Scandium 3 plus is a stable noble gas extra stability. What is that? Scandium 3 plus is ar- argon.
Argon.
Argon. This is our argon and 4s0 3d0. That's what you are saying?
Yes, sir.
Okay. This question has been asked in the paper for your information. Student did not know how to write the answer. They knew the answer, but they do not know how to write the answer. You know that scandium 3 plus is only on oxidation state table, you see only plus 3.
Yes, sir.
Only one element which shows only one oxidation state use as scandium. But here now I am talking in terms of the E naught values. But my topic is standard trends in standard reduction potential of the transition elements. As I said, there will be plenty of questions on this. And we have to be very careful what answer we are giving student, one answer we are giving. Now here, if I consider Zn 3 plus 2, Zn 2 plus value student, this value Zn 3 plus 2, Zn 2 plus value student, which is more
Mm,
stable state.
for Zn 3 plus.
The E naught value here is highest.
Zn 2 plus will be more stable.
This value is highest, I am saying positive. Highest value is not
Okay.
given. This value is not given. So why
Zn
that
2 plus
what
will
I'm
be
saying is Zn 2 plus is more
more positive, more
Zn 3
stable
plus
than
doesn't exist. In fact, we have not seen any compound of zinc in Zn 3 plus. Have you seen any compound? Because this is stable 3D configuration. Stable 3D configuration student. Stable 3D configuration students. Stable 3D configuration. Okay. Can I rub this?
yes, sir.
I hope you have noted each and everything because these questions you won't get anywhere. I am trying to find out as many questions as possible.
Yes, sir.
Okay, note down, then I am removing everything. This is just a brain exercise now. Without thinking, no answer can be given. This also shows how important are these electrode potential values, student. We will find a lot of answers. If the change involves a lower value of E0, then the metal will remain in that oxidation state from where it is coming. If it is positive side, and then metal will change its oxidation state. So it becomes oxidizing or reducing agent depends on the values of the electrode potentials. If negative values itself means they are reducing agents, transition
Yes, sir.
elements. But that transition elements are stronger reducing agent than alkali metals or weaker. Question number, another question. Another question has come student in my mind. This was asked somewhere. Are the transition elements stronger reducing agent or weaker reducing agent than alkali metals or alkaline earth metals? If I compare student alkali metals, for example, if I say lithium to lithium, what is this value? And if I say compare them with transition elements students, if I compare Zn2 plus 2 Zn, this value is minus 0.76. What is this value? You have seen in electrochemical series this value. How much was that? They You have seen these values somewhere in the electrode potential values. This is going to be much less than this value. 1 point something or 2 point something minus.
Okay.
So these E naught values are much lower, are lower than E naught values of transition elements. Transition elements. The correct values are in the table. This this value is lower as compared to this. If this value is lower, then these alkali metals or this will be stronger reducing agents. Stronger reducing agent. In fact, in the table we have seen lithium. Lithium was the strongest reducing agent.
Yes, sir.
Why? Because it smallest size, highest high hydration enthalpy. So you have seen its ionization enthalpy is more, atomization is more, but hydration enthalpy is very high. So answers we have started giving. Got it? So
Yes,
comparisons
sir.
are made at many places, student, at many places, students, when we compare. Now let us see iron, student. Iron 3 plus to iron 2 plus, what is the value given? Plus 0.77. Plus 0.77, students.
Yes, sir.
Now, what is the iron atomic number? 26.
26.
Is it 26? Scandium, titanium, rhodium, chromium, manganese, iron. 22, 23, 24, 25. 26 means what? Argon 18, 4s,
4s2 3d5.
huh? 36, no?
3d6. Yes, sir.
If I have Fe2 plus
It
3d6,
will be 3d6.
Fe3 plus is 3d5.
3d5.
This is a stable half filled. Fe3
Yes, sir.
plus is stable state. Therefore, this prefers to stay in 3 plus oxy. Iron is readily oxidized to Fe3 plus. You know, if you cut an apple, it becomes reddish brown.
Yes, sir.
That value is not that high. That value is not that high. That's what we are saying. This value, you can see plus 1.97, 2 point something, and this is 0.77. So the value is not that high, and therefore the 2 plus will go to 3 plus because 3 plus is 3d5.
5.
Stable configuration. We have to answer the question in the papers, then we have to look into this. Look into this now. What is the story of V3 plus 2 V2 plus students? Where is vanadium? Minus 0.26 volt. V3 plus E V2 plus is E naught minus 0.26 volt. That means the value is low.
Yes, sir.
So
Yes,
V3
sir.
plus is more stable than V2 plus. Question has been asked in the paper, student. Explain what is the configuration of vanadium? What is the atomic number of vanadium?
Vanadium
23.
is 23.
23. When it is 23, then I can straight away write, student, 4s2 3d 3.
3. 3.
Okay. So you are saying it is a 3d3 4s2 vanadium. Then what is vanadium 2 plus?
3D3.
Vanadium 2 plus is 3d3.
3D3.
And what is vanadium 3 plus?
3D2.
3d2. Now, how will you explain this? That 2 plus is more stable question has been asked. Let us change the pen ink because it's important question. What answer you have, student? You have 1 minute. Can you answer this question on this configuration?
No,
D3
sir.
or
No, sir.
D2?
No.
No. But now we are using another thing. We know that the d orbital student, d orbital splits up. The splitting of d orbitals into 5d orbitals. What we are saying, there are 5d orbitals. How many? 1, 2, 3, 4, 5. They split up into T2G and EG.
Okay.
T2G and EG. When the ligands come, students, what happens? That d orbital symmetry is destroyed. We will do this in coordination compounds, which is our next topic. So now you have 1, 2, 3. So this T2G is half filled. So here what we are saying, student, what answer we are giving in the paper, the question has been asked. What we are saying that V3 plus is more stable due to half filled T2G 3 configuration. This is my answer in the paper. I don't have to show this. I've just shown you that this happens. These are our 3D orbitals. ठीक है?
Okay.
Important question, student. Because there was no other answer here. No other answer, student. Somewhere in chromium, in this is my vanadium. This is my vanadium, student. Vanadium. Now I am coming to chromium 3 plus. Chromium 3 plus to chromium 2 plus. What is the value?
Minus 0.41.
Minus 0.41 volt. What is the configuration of chromium 2 plus and 3 plus?
Chromium 4s1 3d5. So 2 plus will be 3d4 and 3 plus will be 3d3.
This is 3d3. 3d3. And this is 3d4, student.
4.
So here, what is happening, student? Which is going to be more stable? This is our T2G3. And this will be what? T2G3 and EG1. One electron goes on the EG1. Or it may go in this itself. It may go in this itself, student. So what will happen? What will happen, student? What I am trying to say, that chromium 2 plus will try to go to chromium 3 plus. Is it an oxidation or
Okay.
reduction?
Oxidation.
It is undergoing oxidation. Therefore, it will act as a
Reducing agent. Reducing
reducing
agent.
agent. Somewhere question could be there. We'll see. Chromium 2 compounds could act as a reducing agent, could act as a reducing agent, students, reducing agents. Okay, how many cases we have seen? Manganese, iron, zinc, extra stability of chromium also we have seen, student. Are there? coming to the more questions.
So, sir, for chromium, which state will be more stable, 3 plus or 2 plus?
Here,
For chromium.
3 plus is more stable here because it is going to get converted into this. It is T2G3.
Okay.
That is giving extra stability to this chromium.
Okay.
Okay. Let me, before this, I have one or two more questions. For example, this question was given. For the first row transition metal, the E0 values are. Explain the irregularity in the above question was given in the paper. You have answered this question.
Yes, sir.
Why the irregularity is there? We have answered this question because
Yes, sir.
there is a irregularity in the ionization enthalpies
And
and the hydration enthalpy.
hydration enthalpies.
Okay, this is question 1. This was asked question. And question 2. Why is the E naught value for Mn3, Mn couple much more positive? Okay. Now we are talking of couple, student couple. Okay. Same what we discussed. You know what is a redox couple? Mn3 plus Mn2 plus. Question could be put in many ways. Mn3 plus Mn2 value, why the value of this is more positive, more positive. E naught more positive. Then Cr3 plus Cr2 plus or Fe3 plus 2 Fe2 plus. Okay, you have 1 minute to answer the question in the exam. Values, I have given you the values. They not need not be given in the
Sir,
paper. He has
okay.
only said more positive. That's all. He has not given values to us in the exam. Has he given? No. So
No.
again, I said you will search in the
Sir, because the
first thing we search in the electronic configurations.
configuration.
So search the electronic configuration. In other words, what we are trying to say, Mn3 plus to Mn2 plus is more positive. More positive means what I told you, which state is more stable, 2 plus or 3 plus. If this
Uh,
given,
Mn2 plus is more stable.
Mn2 plus is more stable because now you will answer the question. Because Mn2 plus is 3D
Mn2 plus will be 3d5
5 more stable. Half filled,
d orbitals.
half filled configuration. Chalo. That you have answered. Now what is happening here? According to this value, in the case of chromium, I have explained to you what is happened. Chromium 3 plus
Yes, sir.
has T2G 3. What about Fe3? Fe2 plus has here out of these two values, what is the thing which is D5 3 plus or 2 plus?
For iron, it is 3 plus more stable.
3 plus more stable. So now you know the answer of this question. This was asked in the paper.
Okay.
Fe3 plus is more stable than Fe2 plus. Therefore, students, what we are trying to search here, the different type of possibilities and questions which have been given. For scandium also, it was given a question. Then we have been able to answer and explain the table of electrode potential values, the table of standard, very important, electrode potential. There will be a lot of questions on this.
Okay.
Different type of questions will be asked. And in further lectures, we will be discussing about the different type of compounds which will be formed, and we'll try to correlate those values with ionization enthalpies, atomizations, or hydration enthalpies, lattice enthalpies, and the values of the standard electrode potentials which we have calculated uh, and given you in the table students. ठीक है?
Yes, sir. Okay.
Now another question was like this: why he says why Cr2 plus is reducing and Mn2 plus oxidizing when both have D4 configuration. D4 configuration. Okay, now you have 1 minute to answer the question.
Sir, for chromium, Cr2 plus is reducing because
Reducing means it undergoes oxidation.
oxidation. So it changes. So it has half filled T2G.
T2G3 configuration. आ
Uh, yes,
गया ना
sir.
question?
Yes, sir.
This was to be written in the paper. If you write anything, zero
Okay.
marks. And what is happening in Mn? And
Sir, from
Mn2 plus is
Mn,
oxidizing. Mn2 plus is oxidizing means it is converting into. This is not Mn2 plus. This is Mn3 plus.
Mn3 plus to Mn2 plus.
Okay.
So it will be half filled configuration. So it will be extra stable.
Mn2 plus is 3D5 half filled. Question depends what type of question is given. This is very important where T2G is becoming more stable. Very important. Question has been asked so many times. Here the students have done mistake again in this question. Got it? This is very
Okay, sir.
important question. Very, very important question. All right, then we will continue with more in this and we'll meet you in our next class, students. Thank
So,
you
sir,
very.
next class it will be on Saturday only.
Yes, you have any difficulty?
No, 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 sir. Just asking. क्योंकि उस दिन वो था ना कि दिवाली थी ना सैटरडे सो जस्ट
दिवाली
आस्किंग
सैटरडे है या कि संडे है?
सर सैटरडे है
अच्छा दिवाली सैटरडे है then we will take it, we won't take if it is a Saturday we won't take. ठीक है?
ओके ओके
Then we will take on Sunday.
ओके सर
Okay, I will tell you.
ओके सर
All right, students.
ओके थैंक यू सर
Okay, good night.
थैंक यू सर